Hey everyone, welcome to the stream. So thanks for joining. Meshu Gasha, Meshu, I'll just call you Meshu. So Meshu, you ask, am I using pure C++ 17 or C++ 11.14, C++ 03? So I don't exactly know what pure C++ 17 would mean, since it's technically a superset and they just added features to the old one, but I do try to use as much modern features that I can that are helpful. So that's definitely C++ 17 is in my code base. I had to actually enable support for that in the MSVC compiler in order to make use of that. And I try to keep it up to date, although right now I think I have, well, that's maybe not showing yet, but I think I'm missing the very, very latest update, but I'm pretty close. So yeah, it's C++ 17 as I put in my stream description. And yeah, just, you know, like I could try to find an example of something in there. Yeah, modern C++, yeah, exactly. So, you know, the kind of thing you'll see is like, I think in my debugger, a good example is I make use of, what's it called here? So like I think I return a tuple somewhere and then I use structured bindings. Tuple, do I have a tuple somewhere? Oh, in my render here. Like here's an example where this function create line and point and vertex arrays returns a tuple of vector of two vectors. And when you go look at where it's used, well, in this case actually I use standard tie, so that's not really a good example. Do I have another one? Maybe this one here, get major minor version. No, where do I use? There we go. So here's an example of a C++ 17 feature on this line, where I'm using structured bindings to destructure the tuple that gets returned by this guy here, this tuple of int into two int references here. That's one example of something that wouldn't compile without C++ 17 support. So yeah. And then there are a few other things like that. I'm making use of the file system library, which actually MSVC doesn't have fully integrated yet, so it's still in std experimental for them, but yeah. SDL, why no GLFW? What's that again, GLFW? I mean, unless I am using GLFW. Yeah, I mean, I suppose I could use this. I mean, the reason why I use SDL is for more than just the OpenGL part, right? I'm using SDL for the input, the fact that it can create windows, the fact that I get, there's audio support, there's network support, so there's a whole bunch of stuff that comes with SDL. And then as for OpenGL, in this GL render here, you'll see that what I depend on, I use GLM, and what else? I use ImGUI, which has nothing to do with OpenGL actually, but yeah, I think my only real dependency is GLM. A GL help utility or something. I use glue as well, but yeah, basically I use a lot more SDL than I use. Yeah, that's for the math stuff. GLM is for the math stuff for sure. But yeah, this thing GLFW looks interesting. I mean, I'm guessing it can be mixed with SDL without any problem. But you know, I kind of found it interesting to do my own direct OpenGL stuff. Also as a way to kind of learn it. I'm guessing GLFW is some kind of wrapper or something. I don't know. I'd have to take a look at it. Yeah, it's cool. I'll take a look at it. Yeah. I mean, to be just this example here makes it look a little bit like SDL. You know, SDL kind of has a lot of these kinds of functions, but I'm sure there's much more to it than just the basic stuff here. The Vulkan stuff looks cool. The fact that it actually has Vulkan support, that's pretty nice. Receiving inputs, okay, so it's got inputs as well. Oh, it looks cool. I'll definitely check it out. So yeah, actually before I started, I just wanted to kind of call this out. So this is kind of cool. On my last stream on episode 57, which was a couple days ago, I got a comment from Vid, or I don't know, Vide, I guess his name is pronounced. I'm not quite sure. Vide Malban, who is he's like, I think one of the most important people in the Vectrex emulation or Vectrex software support community. He's the author of that vid. Is it vid.malban.de here, or Vide? I guess I say vid because I'm from Montreal, so I pronounce it in French, vid, but I'm sure it's probably Vide or something like that. So yeah, so basically this is like the greatest like Vectrex IDE that's been put together. It's really quite cool. I don't know if anyone's interested in doing Vectrex development, you definitely want to be checking this out. It's this multi-platform Java-based IDE where you can program for the Vectrex. It's got like an integrated emulator, debugger, with full support for debugging, stepping, like all graphically. It's got lots of tools. It's really, really great, really very impressive. So it was kind of really nice to get a shout out from him. He actually said something that's pertinent to what I'm working on here. He said that he wanted to point out that when we're trying to get 3D Mindstorm to work, and as he writes here, the official Imager games have a startup phase. During this phase, the Imager is powered up with heavy-duty cycles until the speed of the wheel matches the above-mentioned time frame. So there's like a wheel in this Imager. He says during that power up button 4 is pulled. So this is on the second port. So joystick 2 button 4 is pulled to see if the sinkhole of the wheel is triggered. So I guess what that means is that when the sync wheel, like when the wheel lines up, it sends a button press for button 4. So yeah, definitely a great honor. And he says here, no usage of interrupts in the startup phase. I'm not quite sure what he meant by this. I think he meant there is a part where it's not really, interrupts are not being used in terms of like calling an interrupt handler. But we saw actually that there is an interrupt handler that will get called, and then he says if you want to go further with 3D Mindstorm, you probably must implement Imager emulation. So, which is true. I think he's right. Like, I don't think we're going to get very far. We know it's an Imager game. It's a 3D Imager game. I just am hoping once we get the interrupt stuff working that we'll at least just see something. Like, we'll see maybe the intro screen and won't be able to go much further. But that's fine, right? And then we should check other games that seem to have dependencies on interrupts. And he also points out, but this I knew, that in the disassembly, when we hit the CWAI instruction, that it's not actually showing correctly in my disassembly view. I'm only showing the instruction name but not the parameters, and that's totally expected because I haven't implemented this instruction yet. So I just point that out here. And in fact, I tell him that I was surprised that he watched my stream and very happy about it. And he says that he doesn't always watch, but he is interested, and he says that he watches it, like on YouTube, and he notes something that I said something about his documentation, some correction that he's going to make. I don't remember. And he says, I pondered to keep quiet since you are doing a very good job at exploring yourself. So I appreciate that. And he said, since probably one or the other things I emulate are wrong, it is best to have someone independent look over it, which might in the end result in a greater Vectrex knowledge. Yeah, I doubt it. I doubt that I'm going to figure out something different and correct that he didn't get right, because yeah, I mean, a lot of the stuff I'm getting comes from his own docs, right? So But you know, never know. But thank you very much, Vide, for checking out my last stream and for your comments. I really appreciate that. Okay. So yeah, so last stream we made some nice progress. We were working on the interrupt handler for the IRQ that gets raised from the VIA chip. So there's a bit of work that I did there, and so I'm gonna continue to work on that. Yeah, let's see where we get. I'm not gonna go over my changes because if you watched the stream just 2 nights ago, you will have seen everything I did. So yeah, let's continue. So where we were at last time, I was working on the CPU. So now I get whether IRQ is enabled or not. When it's enabled, we check if the interrupt mask is cleared. So if this is 1, it means that we're masking out interrupts like IRQ. But if it's clear, it means we want to. We're going to be pushing the entire stack, so we have to set the entire flag in the control codes register. And we do this before we push it, because we're going to push it here, because when we pop, we're supposed to look at whether entire is set or not to know whether we need to pop all these registers or only pop CC and PC, and then none of these in the middle. So that's what that's going to be used for. And I mean, in our case, it's always going to be popping everything because we're just doing IRQ, but when we handle FIRQ, that's where we will only push PC and CC. And so then in that case, we won't be setting the entire flag. If anything, I guess we'd have to make sure it's cleared. Then, and then we got to the point where, yes, after doing that, we now start masking out interrupts. So we have to set this to 1 after the fact, I believe, from what I saw. And yeah, I guess that would make sense, because then when we pop this, we can receive interrupts again. We read, this is the IRQ. I guess I should probably put this behind a constant. I really shouldn't be hard coding these values. Let's see. Because I think I have another one here, 0xFFFE here. So we should probably put these behind some kind of little, what can I call this? Maybe vector table, and let's see what values we can put in there. So we'll have one for resets, but that's for sure. So this will be reset here. And this one will be IRQ. So something like that. All right, next. Okay, and then after that we say how many cycles, and then we return that. So this should work. And then what we should be getting is we'll be jumping to the ISR, to the interrupt service routine. It'll start to execute, and then we will hit a unhandled op, which is CWAI, which is the one that he was saying does not disassemble correctly. Okay, so let's speed this up. There's our black screen. I'm going to press F, which is button 4 on joystick 2, to simulate the input from the imager. And see, actually, it's kind of cool, right? We start to see the rendering of the ship. So I didn't even notice this. That's pretty cool. I didn't notice this at the end of last stream. It was probably there, but I did not notice. Yeah, so you got like the score and something here, and I guess that says 3 ships left, our score. And we can see there are 2 instances of the ship, and that would, I guess, make sense because I guess they're rendering at slightly different offsets, you know, for even and off fields, even and odd fields or something. I don't know, like I think it's for the cycles of the imager's thing, that spinning wheel, it's gonna render and synchronize to that interrupt and decide to show one side or the other or something like that. So, you know, give that 3D effect. What do you call it? What is it called again when you do that thing where you split the 2 images to give the 3D effect and you show one in one eye and you keep showing one in the other? Total brain fart. Anyway. Okay, so yeah, there's our unhandled op, and if I show the disassembly, this is the line that Malbin was speaking about, that we haven't fully disassembled it, but that's normally what we get when I haven't implemented the operation. So let's see if we can work on CWAI. Okay, so usually, where did I put that? Oh, it's here. So usually I use this document here, and actually I started reading about this a little bit. You can write NASM? What do you mean I can write NASM? For me, NASM is basically the name of that assembler. I think I used that when I was learning assembly back in university. Do you mean, are you talking about the assembly that you see here? Is that what you're referring to, Meshu? So this is basically a disassembly. Norton assembly. Right. Yeah, so you were talking about Norton assembly. But why are you asking if I can write it? I'm assuming you're referring to the fact that you see this assembly code here. And this is basically just my debugger is showing the disassembly of the last, say, 10 instructions here. You know, if I want, I can show, say, the last 100 instructions that executed. And so I basically render here the address of the instruction, the instruction in hex, the disassembled instruction, the way you would probably write it in assembly. And then here I have some extra information, comment section, how many cycles it took, and then the values in each of the registers, A, B, X, Y, U, S, DP, and then here are the flags, the control codes, and if it's set, it's capital, and if it's unset, it's in lowercase. And I have a whole bunch of like cool things I can do with my debugger. So I can set breakpoints and watch points and a whole bunch of cool things that I've been using to help me figure things out. You're using Linux, you have different registers. So this is basically this is not the registers of Windows or Intel or anything like that, if that's what you mean. This is basically, I'm emulating the CPU for the Vectrex, which is the 68A09 or the 6809. It's an old CPU, and these are instructions. This is the instructions that would run on that CPU, and these are the registers that would be available on that CPU as well. So I'm just emulating that on top of, in this case, Windows and on an Intel chip. So yeah. Okay, so let me see here. So this is clear and wait for interrupt. So the way this works is you write CWAI and you give an immediate value that is an address. What we're supposed to do... Oh yeah, you don't have to apologize, man, it's fine. It's just sometimes I just want to be sure I understand the questions, right? So yeah, so like, just to reiterate, like this is an emulator for the Vectrex. The Vectrex has its own CPU, it has other chips that I need to emulate, And so what you're looking at here is really the CPU implementation, like the CPU emulation. So I have this file cpu.cpp, and in there is all the code that, you know, basically takes each instruction that might execute and then kind of simulates or emulates how it should behave. So that's really what the crux of an emulator is. An emulator is basically writing code in like a language, like here in this case it's C++, and kind of building an abstraction layer that is you can think of it as a virtual machine, right? Like if you know a little bit about Java, since you've started, I'm assuming you know a little bit about Java or any of these languages that have a virtual machine. You can think of this as a virtual machine, and the instructions are in another language, and then we kind of take those instructions and execute them so that it runs on the host machine, which in this case is a Windows machine. And then of course this should be easily portable to Linux or Mac or whatever. And at some point I'll actually port that on stream, so at least to Linux. I can't really port to Mac, I don't have a Mac, but I can do Linux. So yeah. Let's see here. So CCR. So what we're supposed to do is we're supposed to take. Okay, it's not an address actually, right? What is this supposed to be again? It's. Oh no, it is. Okay, we're supposed to read the memory value that is specified at this address, and then take that value and AND it with CCR. Oh, it's my pleasure, man. So we're supposed to AND it with the value in CCR. So this means that by ANDing it with zeros, we would be able to clear specific masks. So if you have like a mask, if it's all ones at that thing, it would basically do nothing to our flags register. But anywhere where you insert a 0 is your chance to clear certain bits in the flags register. So that's what that's about. And I mean, I suppose it's probably going to use the same circuitry. I think we actually have an instruction, right, for setting the bits. What was it called again? Let's see here. Op AND. Yeah, just ANDing. In this case, you AND with a register. Let's see. Well, I guess it's not this. For AND CC, that's it. Okay. Right. So if you do AND control code, you kind of get the same thing, but without the extra stuff. So maybe, you know, it'll look a little bit like this. Although here it says for AND CC, we don't update CC. For AND CC, we don't update CC. So I guess in the end, it just stores the result in the register. So AND CC is kind of special, right? So it says compute what the result would be from ANDing the value against CC and store that into the register. Okay, so that's a little bit different, but here we actually do modify the CCR. So we're going to be doing that. We want to set E, and then we do once again the same kind of push. So it looks like we're going to want to put that push logic into a little function, since we're doing exactly the same thing again. Here they give some possible values you would feed in, or you would store in memory, I guess. Yeah. So FF means enable neither. Oh, okay. Right. Okay, right. So to enable IRQ, you would pass an EF, which would basically be setting 0 into the I bit here, whereas BF would be setting 0 into the F here. So by setting these to 0, that effectively enables them, right? Yeah, exactly. So that's it. So, and then here, if you want to enable both, you use A, which sets those 2 bits. It'll set F and, or unset, I should say, F and I. So I think that makes sense. Okay, there's more to this operation than just doing that. There's also this wait for interrupt. So that's kind of interesting. I don't think I've ever seen an instruction that puts the CPU into a wait mode. So let's see. The CWAI instruction ends an immediate byte. An immediate byte. Is it immediate? Oh, I guess it is. Maybe I'm misreading this. Because here it says immediate value, then $XX, giving me the impression that it would be 2 bytes, but really it should probably just be $X. It's a single byte. So yeah, I'm not sure what that's about. And here the fact that it says MI is also confusing. Because this is definitely, being an inherent instruction, 2 bytes, yeah. So it's just getting an immediate value. Okay, so we get the next value, and what does it say? It says we AND the immediate byte with the condition code register, which may clear interrupt mask bits. It stacks the entire machine state on the hardware stack and then looks for an interrupt. When a non-masked interrupt occurs, no further machine state will be saved before vectoring to the interrupt handling routine. So that's what's special about this is, you know, you want to start waiting for an interrupt, and you just want to kind of, I guess, halt the CPU or like kind of make it spin and wait. And as soon as one of those interrupts occurs, so clearly you're going to want to have enabled one of these for that to catch it. Yeah, I don't know if it would make any sense to not have one enabled, but anyway. Although setting FF doesn't mean that you won't get one. It all depends on what's currently set in I or F. So anyway, when a non-masked interrupt occurs, no further machine state will be saved before vectoring to the interrupt handling routine. So we immediately jump to the interrupt handling routine. This instruction replaced the 6800 CLI-WAI sequence, but does not tri-state the buses. Okay. So memory immediate. It says memory immediate. Comments. An FIRQ interrupt may enter its interrupt handler with its entire machine state saved. The RTI will automatically return the entire machine state after testing. So here they're saying that, you know, it's a bit unusual, but FIRQ is called FIRQ because it doesn't have to save the entire machine state. But if you started with a CWAI, it will have pushed everything and set the entire flag. So if an FIRQ does fire, it will end up having to pop the entire state, even though normally FIRQ is used to not do that. So I think that's what that's about. So that makes some sense. Okay. Inherent. Yeah, so I'm not entirely sure how I'm going to implement something like this. It's also a bit weird that it's called inherent here. It really should be immediate. Yeah, I think this is incorrect. And I'm just going to do another check. Let me just go look at another doc. So I like to kind of cross-reference these. Okay, let's look. Whoops, not here. Let's look in. Oh yeah, I have it open somewhere else. And it's docs, CPU. Start with this one here. Whoops. Okay. Opcode fetch. CC mask is at PC +1. Okay, so it really is an immediate mode. And this one here goes and does all of this. 16. So here I'd say 16 cycles, whereas here we write 21 cycles. 16. While interrupt not, so don't care. While interrupt not present, we just wait, I suppose. And then afterwards, okay, so basically it's 21 in total once the interrupt has occurred, I suppose. Huh. Yeah, it's kind of interesting this because the way I wrote my emulator is that if we go back to the debugger, I'm not sure exactly how I'm going to do this, because the way it works right now is we execute an instruction and we get a certain number of elapsed cycles, and then we update the VIA with that, right? And it is the VIA that's going to know whether IRQ has been enabled or not. And so, so I have a situation here whereby we will, you know, when we get to CWAI, you know, I'll return, let's say I return the whole like 21 cycles, even though we haven't finished, or even if I was to return 16 and then, you know, wait until the rest has occurred, or maybe not 16, say 17. Okay, sorry, it's do while. Unless this counts as a cycle, maybe? Maybe that's what I need to do. Keep counting this as one cycle, then that would work. So I return 16 and then we update the VIA, and then after that I enter a loop where I keep saying for one cycle I'm just waiting. So then that's going to keep returning and then telling this VIA to update one cycle at a time. Eventually, yeah, it needs to have at least one cycle, I think. That's the key, right? Or does it? I don't know. Maybe it doesn't. Yeah, I guess it doesn't really matter, even if it's 0 cycles, because we do check input and stuff like that. So as long as we're updating it with 0 cycles or not, it's fine. Okay, yeah, so there's no issue here. I was just concerned that maybe passing 0 cycles would mean nothing would happen, but that's not the case. Alright, so how do I do this? I kind of need a little state machine going on here. I need to know that I'm in the mode of CWAI, that I'm waiting for interrupts. So I'm going to have to add some kind of boolean here. So Meshu, you're asking if I'm using shaders. I am indeed using shaders. Initially I wasn't. Initially when I did it I was using immediate mode OpenGL just to draw some lines, and now but then I've since replaced that with shaders. Okay, so let's go up. Let me put a little. Waiting for interrupts. You know what? I've been kind of getting in the habit of using uniform initializers, so I think I'll change all these to do that. And so here I'll say set by CWAI. So if we go back to here, we're waiting for interrupts. So if we're waiting for interrupts and we have not gotten our IRQ enabled, or maybe I'll do this way. Say we're waiting for interrupts. Now, if IRQ is enabled, we have some work to do. Else, so we've gotten no interrupts yet, and that's the part I'm going to focus on now. So that's going to be the bottom part here. Or, well, basically it's we don't care. So we're just going to return 0, 1, I don't know. Let's say 0. Now, if this does happen, we're going to have to jump to it. Which is what we do here. So I guess in fact I could. Actually, it's more than that. We need to pop. No, we just need to jump. And maybe... doesn't really talk about that, does it? I'm gonna guess that we want to basically do the same thing here. Also, make sure that the interrupt mask gets set here so that we don't get interrupted again. I think that's kind of like the way it goes. If you do an interruption like this, that's what you're supposed to do. Okay, so let's say this. Eventually, I'll also have an else if FIRQ here. And then otherwise we are waiting. Oh yeah, and we need to actually turn this off. Oops. So we would be no longer waiting. Okay. So while we're waiting, we're going to come in here. If IRQ is enabled. We're no longer waiting. We go and actually jump to the IRQ handler, and we're good. All right. Okay, and I'm gonna put this into wrap this up into a function here. I'm gonna need a function. I'm gonna call it push CC state, and I'm gonna tell it whether or not it's entire or not. And we'll do like this. Yeah. So this will be replaced with a push CC state true. I'm not sure. And okay, now I need to implement CWAI. So go back to the opcode table. I'm quite sure this should be immediate. Now that I look at it here, I think that would make sense. CWAI, so this becomes immediate. 0x3c. And this is on page 0, right? It is indeed on page 0. All right. So let's go to op bit here. Maybe op end. This is one of those that takes no parameters because it's an immediate mode instruction. We get it by looking it up with the addressing mode, which will be immediate, so we should get back our value here. And what we want to do is we want to set the CC value to the CC value bitwise ANDed with the immediate value. But actually, do we do that before? Yeah, it is. We do that first. And then after that, we want to do a push state, push CC state, true. So you want to push the entire state. And finally, we want to set, what was that thing again? Is m underscore wait for interrupts equal to true. And I'm going to make sure that, what again, is it assert? I want to make sure that we end up not calling, I don't think it's valid to call this twice or call it while we are waiting for interrupts. That just doesn't make any sense based on the state machine and all that. So it should be false, and then we'll set it to true, and then after that we'll be waiting. Okay, so I think that's op CWAI. So yeah, let's see if this builds, and then we'll set some breakpoints, and we'll see if this actually gets us further. And I think what we saw last time is oh hey Meshu, oh have a good night, man. And 6 o'clock in the morning, wow. Well, thanks for hanging out, appreciate it. Oh yeah, that's fine. It's why I put these on YouTube, right? Oh yeah, it's fail message. Or maybe actually no, it's assert that I want. Yeah, I just want assert. Okay, so assert that we're not waiting for interrupts. Oh yeah, that's true. Now we made this larger. So my pimple size has grown. By probably I don't know, would it be 36? Good night, man. Just make it 48. Okay, so everything builds. Let's set some breakpoints. So I want one in here. If we're waiting for interrupts, I'd just like to see that we get into this little state machine here. I want to know when we enter here. so let's try this. We'll fast forward a bit here. 3D Mindstorm, blank screen. I'm gonna hit F here, which is joystick 2, button 4. All right, so we got our IRQ from the VIA. We're gonna do a full push. I'm just gonna step in here, just make sure this gets there. We push, 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 push. CC value, so CC here. Fast interrupt mask is 1. And entire is 1, because we set that. And the rest is 0, okay. So we push all that. Then we are going to jump to the IRQ's location. We can't actually, this is not valid. We saw this last time. And why? Oh, I think this got optimized. This code here, I think, got optimized. That kind of sucks. Okay, let me stop again. I'm just gonna disable optimization because I really do want to just make sure we get inside here. Optimize off, I think it is. Is that right? Yeah. You'll notice I keep rubbing my back here. I actually kind of hurt myself. I don't know how, but I kind of pulled something in my shoulder and it's been hurting me for a few days. It's on my neck here. Anyways. Okay. So we're here again. So we push this. And I just wanted to see if we can still put our breakpoint in here. Ah, it sucks. Yeah, this optimize off and on thing doesn't seem to always do the trick. I thought Pragma optimize off here was supposed to make sure that this code would not get optimized. My guess is maybe because it's a template, it's still being inlined. I was hoping for it to not be inlined. So maybe it's not about optimize off, it's more about no inline. Let me try this, no inline func. That's probably what the problem is here. Let me do both. I think this has to be put here. Yeah, okay. That should do the trick. It's both unoptimized and uninlined right now. Okay, that looks good. We have our breakpoint where we wanted it. Great. So we don't need this. And we don't need that. Okay, so we got our blank screen. I'll hit F. And there's our CWAI. So let's see. We're gonna get a value, which unfortunately, despite the fact that we're supposed to be unoptimized, I'm not seeing on the value here. Nope. Let's see. BL. So I guess BL contains our value. This is EF. So EF would mean enable IRQ. So yeah, this CWAI should show $EF in the debugger if we were to stop the debugger, which I'll try and do. So we push the full state, we set be waiting for interrupts to true. Yeah. Hit F5. Now we are waiting for interrupts. Our IRQ enabled is not set, so we're going to start returning 0. So I'm going to put a breakpoint inside here. And I guess returning 0 cycles is not going to work, right? Is it? What's happening right now? Yeah, the problem is okay, that's it. That's what I was worried about. Is that we have a certain number of cycles we need to eat up for this frame. So we can't be returning no cycles here. We need to return something. And I don't know if I should be returning 1. I mean, I can almost return anything, really, at this point, while we're waiting. Like, let's say I return 10, just to say. Basically, we just want to return some number so that we eat up our frame, give it a chance to render. I gotta think about what is the logical thing to do. F, push, CWAI. Now we're waiting. So there we go. So now we're getting a render. And just out of curiosity, oh, that's interesting. That's it. My debugger is trying to figure out what the next instruction is, and it's seeing a load A. And so it's actually logging that as the next instruction we've executed. Because this is really a special case, right? We're not really executing an instruction right now. We've moved past the CWAI to the next instruction, which looks like it would be an LDA. And then the debugger is saying, oh, okay, so we're constantly executing LDA, but we're actually not executing it. So this is kind of a special situation. So this is messing up my trace. So that's something we're going to have to fix. Such a weird special case. Anyway, let's say we continue and then I hit F again. So see, by hitting F, again, thinking about that would be the equivalent of the imager sending or like raising IRQ every time it would spin, and this would happen some number of times per second, right? Again, we're just simulating it. We see that waiting for interrupts was true. IRQ just got raised. We set it to false, and we are going to now jump to the IRQ handler, right? So we set interrupt mask to 1. And I mean, I guess we should be getting a RTI soon, shouldn't we? We get another CWAI. Okay, so we're not hitting the RTI case. That's what's happening here. See, if I hit F, look. So I'm simulating. Very interesting. Like I'm going as fast as my finger can go, right? I guess I don't have repeat. Minefield 1. Very interesting. Let's make this a little bit bigger. Huh, look at that. They're moving apart. So there you go. Like I'm simulating the really fast input press of the imager here. It's hilarious. And notice if I stop, it fades to black because that's what the shader does, right? And I mean this lines up with what Vide was saying about making sure to that I won't get very far without emulating the imager. And I suppose in this case that means at the very least sending that IRQ at a certain rate, or like sending this button press at a certain rate. So there you go, I can turn. Okay, I can do my... Yeah, so this game is basically entirely driven by CWAI. That's what it would mean. And I guess that makes sense, right? Like, this is a game that's written, that's driven by the imager, the 3D goggles that are, you know, sending a pulse for whenever the wheel turns at a certain place, and that pulse tells the game it's time for you to do your render for this, you know, this frame, and then it does the render, and then the next pulse gets set and it does the render. So I guess it has a kind of a, you know, time where it needs to do the render quickly before the next pulse comes in for it to actually be responsive. Okay, now I don't know why, but oh, there, I paused. Can I actually fire? Okay, this is the move button here. This is the fire button here. I mean, I suppose if I just constantly pulse, alright, I know, I'm not constantly, pulse at a certain rate, spam this button at a certain rate, we should be okay. I could probably hack that in pretty quickly. The question is, what is that rate? Let's see. So in the STL engine here, so I have this update input here. Maybe I could do it here. A quick little hack. We'll make a static and we'll say next, whatever. Or let's say in seconds, right? So let's say we want to do this. Let's say once at 50 Hertz. And we'll say time left minus equals to frame time. If time left is less than equal to 0, then we'll set input dot set button joystick 1 index 3 to true, so we set that on and then we reset our time left. So I'll put here a const imager so something like this. Okay, so let's see if this works. So we're basically going to make it spam at 50 Hertz. Let's see if that, maybe that's too fast. I don't know. We'll see. That's probably not that fast. Okay, so I think it's too fast, which is why we're seeing all these weird things happening. So let's try a different speed. Let's try 10 FPS. Okay, that's looks a lot closer to what we had earlier. I'm gonna try a little bit faster. Let's do 25. I'm guessing because, you know, the refresh rate, if you will, like the logical refresh rate of a Vectrex is about 50, so maybe half of it. I'm sure I can just look it up. Something went wrong. Try 20. Okay, that's faster. So let's see if we can play this. Well, it sort of works. I can't seem to shoot all of them. These ones here, I'm not hitting them. So maybe the refresh rate is part of the problem here. I'm not sure. And you see they grow. This is probably not the right speed because I find the game quite sluggish. Why don't we try and take a look for what the speed should be? Emulation Imager. The wheel has important information which are needed to display the game correctly. The colors, the angle of the colors, the position of the index hole, the default speed of the wheel. This information is not required, but emulating the pulse width modulation slows down the startup of a game. Using the default speed is a quicker way. The default speed is game related, not wheel related though. Huh. It makes sense to create own wheels, even if the layout is identical for each game, since the default speed varies between games. Okay. So in this mode, the speed of the wheel is fixed. The user or the setting can set or change the speed of the wheel. The Vectrex program has no influence on the speed. If the game is known, this setting is the better looking version. All known games use during its life cycle only one rotation speed, so the value can be preset. Okay. Automatic Imager. In this mode, the speed of the wheel is calculated by obtaining and calculating the pulses the Vectrex sends to the Imager hardware, CPWM. At the beginning of an Imager program, the Vectrex sends heavy-duty pulses to get the wheel up to speed, which takes a few seconds to emulate, and then regulates the speed continuously while the game is running. The wavelength of one sequence is always the time between two sinkhole passes. Switching from automatic to manual is no problem. Switching from manual to automatic is sometimes unexpected results. All known games feature 3 colors, but actually the number of colors is arbitrary. Placement of the index hole on the wheel. This is the reference point the Vectrex program uses for internal calculation of when to draw vectors. In real life, a phototransistor and a LED are placed opposite of each other, and only when the index hole is in the right position, the light of the LED reaches the phototransistor. This transistor switches button 4. So that's what I was saying earlier. So there's this hole and there's a light, and then it spins, and whenever it reads that the light goes through this hole, it sends a button 4 press, and thus sends a signal to the Vectrex. Button 4 is also connected to the CA1 of VIA and can thus be configured to trigger an interrupt, which is the case here. The index hole is not in the same position in relation to the above defined 0 degree for the 2 known official wheels. Okay, so maybe we'll get the number here. So here's a spin per second, 26.0372. So that looks like the fixed rate, I'm guessing. Although here it says auto. So let's try 26. 0372. All right, why not? This is so cool. This one you see like this is like world class, excellent software. All this nice UI, you got the real imager and everything. This is truly a labor of love, what V-Day has put together. Yeah, that's the thing. This is what I got earlier. I get this invalid cartridge read. So that might mean that there is some kind of bug with my implementation, or the fact that this rate is too fast. You know what? This might be related to the returning of 10 cycles. I might be giving too much time. Could this be? Could it be related to that? I'm not sure. Just to rule it out, I'll try returning 1 here, but I don't see what the relationship would be here. But it feels like as if the problem is that an interrupt is occurring while we're, although the interrupt would be masked, so that doesn't make that much sense. I'd have to debug this correctly. Why would we get this? Super weird. Yeah, it seems like I bumped this up a little bit and then we hit some kind of weird threshold where it just doesn't work anymore. Although there is something I'm not quite doing right, I think, is I'm not sure if I'm handling the number of cycles correctly for CWAI. Okay, so it looks like at this time, at least at 24, it's going at a pretty decent speed. Yeah, this feels a lot more on board. See, like, why am I not hitting this thing here? Are those not supposed to be actual mines? Right to unmapped range of values. We're also getting some rights to weird ranges. Okay, it looks like we're almost there. And we won the first round. Oh, cool. Actual 3D shapes there. It's got some pyramids spinning. I'm sure there's lots of stuff that's not right here. Like, for one, I don't see the stars being rendered, and I have these floating objects here which I feel probably shouldn't be there. Anyway, at least we got something, right? It's not perfect, but we're getting somewhere with this, so that's pretty good. Okay, so let me go back a little bit to the code in here. So definitely need to do something special. So maybe what we could do is we could return 0 here and use that as information for when we are in the debugger here. So when we do execute instruction here, pre-write, and then we have this post-op, okay, so we execute here. Now, the scoped exit here, what we can do is we can say, if elapsed cycles is 0, if it's 0, return. And I'll say here, if the CPU didn't do anything, don't log the trace. Or we have nothing to log or hash, which is what we're doing down here. And then we'll do a special case here. We'll say or via cycles. And we'll say this here, elapsed cycles. What do I call this? I'll call this CPU cycles. So if CPU cycles is equal to 0, let's say it's 10, otherwise it's 0. I'll pass that in here. And then the question does become, what do we return? Do I care what the cycles are up here? Looks like I actually don't. No wait. This is for the function execute instruction. Execute instruction, so it looks like I don't really care. Why am I returning it? You know what, I just won't. If I don't care about it, I won't return anything. And I'm going to just disable the code I wrote in STL engine for a second. What's going on here? Oh, wait a minute. Okay, I'm not too thrilled about doing it this way, but let me just see if this is the problem. Why are we stuck in here? it really hurt my back. It's crazy. I wanted to see if we hit this breakpoint. This doesn't make much sense. Let me go back to the CPU. Did I do something weird? CPU cycles 0. Execute. Yeah, this is not right either, technically. So what is happening? What we will do is we'll set a breakpoint on mbreak into debugger because something is causing us to break. But I don't know what it is. So this is false right now, so let's put a hardware breakpoint on that, or data breakpoint. Oh, okay, so we got a break into debugger that comes from this. Why? Oh, okay, because I removed this return state. Ah, yeah. Okay. So, if we don't really want to return anything, we can just do return. Let's try that. Okay, cannot convert from void. Also, we do want to know the elapsed cycles here. Right. Oh yes, and this comes back to we do need to elapse some time or we'll never exit this update loop. Okay, so in that case, that means that what we'll want to do here is we'll want to return I don't know, I'll call it something like effective cycles, which is a name for when you don't have a good name. But I don't. What's the problem? All right. I'm such an idiot. All right, we're running again. Okay, that's good. Let's go back to not debug mode here. Let's go back to release. Now what are we looking for? Oh yes, I know what I want to check. So now technically, I do need to not do this though, but technically we should no longer be tracing past the CWAI. We should have a black screen. It's waiting right now. If I hit F, we got that. Now I'd really love to get it to show, like right now. There we go. Oh, it's sorta. So we can see that right now when I break, the last logged instruction is a CWAI with the immediate EF. And then I have here, right. Oh, that's super interesting. So this line is totally legit because it's showing that when we executed this instruction, we ended up making all of these writes, which corresponds to all of those pushes that we saw. It's a really long set of writes to all of these addresses, which is basically where the stack pointer was pointing to. See, right now at the end, the stack pointer is at CBDE, but when it started, it must have been at CBE9. You know, and then it basically stacked up everything. Going downwards, actually. So then, yes. Cool. So like right now, if I step, see, it's just going to keep reporting as if it's executing a CWAI, but really, it only executed one of them. So kind of step is a bit of a misnomer now, but you can see that the address here doesn't change. We're always at 0463 while we're waiting. That's really interesting, right? And then once we get that, we're going to go past this instruction, which is 2 bytes. So if I was to set a breakpoint on 0465, which is 2 bytes ahead, and continue, and I hit F, I should hit that breakpoint. Boom. So see, we passed CWA5, where it's at we're at 0465 now, and so then this continues the code, and then this code, well, I don't know what this does, but it does a whole bunch of stuff. And we continue, and then once again, if I hit F, we trap into 0465. Cool. So yeah, this is not bad. I would like the instruction count, though, not to increase unless we actually executed an instruction. I don't know how I want to write this, but I guess this is okay. And actually, I think here we want to return as well. I think we always want to return. Because here I set PC. Yeah, so this is the part where I'm not really doing the right thing in terms of cycles. So that might, okay, that might explain the weird thing we had before. Maybe. "16 cycles." Yeah, this really looks like it wants to do 1 cycle here, but it's gonna mess up everything. And this looks like it would total, in fact, 20 cycles. I don't know why I have 21 in my table. Let me see if I have another source that would say the same thing. K. So yeah, it says K there, so it doesn't give a number of cycles. What did it say for K at the bottom here? K. Nothing. "21 in this table. "20 here. Okay. That makes much more sense. So why don't we do this? We'll go and change our CPU opcodes here. So I kind of have 2 choices. So definitely I could put 20 here, but I could put 16 here, since the very first part of CWAI will take 16 cycles, and then once we've completed like handling, or once we've gotten, let's say, the IRQ here, I could return the last 4. So that's one way. Or I can just say return 20 right away, and then always return 0 while we're waiting for interrupts. So then, you know, it's kind of like we've paid for the cycles ahead of time, which probably won't make all that much difference in terms of emulation. I'm gonna do this. I'm gonna leave it like this because this, even though it's less correct, it's definitely simpler. I won't have to do anything weird here. And what we'll do is I'll return 0 here. I could return 0 once, but there's like a different rationale for the return 0 in each branch, so I kind of want to keep it this way. Okay. So at this point, let me just do a quick check over my diffs because I'm starting to accumulate a lot of diffs here. Yeah, lots and lots of changes in here. Okay. So I'm just going to do one more test. I'm going to test again with the SDL engine's pulsing of the CWAI. Okay, so that looks good. And here on our trace, there's the CWAI. SDL engine. Let me bring this back. And then we'll try again at a 26 because I'm just curious if the fixes I just made might affect how this behaves. So we'll take a look. I doubt it though. I think it'll still mess up for whatever reason. Oh, no, I got the invalid cartridge read. It really seems to be like a timing issue. I think if I run it again, at some point it'll just start working. And it's possible that this has something to do with the fact that I'm currently spamming the button like all the time from the moment we start. And maybe we want to start spamming it once we're waiting. It's probably something like that. Because from what I read from V-Day's doc, see, this time it worked. Yeah, so let's try something a little different. Let's do this. We'll put the 26 here, but we'll put another little static here that says like, let's start this you know, do it. If do it. I mean, this is all hacks, right? I'm gonna make it volatile just to make sure that it doesn't get optimized out. Making it volatile is just a little trick that typically will not allow the compiler to optimize the variable out, which is useful in release builds like what I'm running right now. Okay, so now we're in the state where we could turn it on, so we'll put a breakpoint here, and sure enough, do it is available. So we'll set this to true, turn off the breakpoint, and we'll go. Okay, there we go. So yeah, I think what we were experiencing before was the fact that normally the Vectrex the game has to tell the imager, okay, now you can start spamming the button press to let me know about your sync. But we were doing it so that it was spamming it too early. Okay, so this looks like probably the right speed for the game. It feels a lot like the original Mindstorm. All right. Okay. Let's see if I can get some stuff checked in now. Actually, let's open all of this here. So yeah, I don't think I'm going to check this one in just yet. I'm going to have to think a little bit about this. We'll probably want to have some kind of option to turn on this imager emulation, which for now will just be something like this. Okay, so we moved that. We've got CPU cycles. If the CPU didn't do anything, waiting for interrupts, we have nothing to log or hash. So I got this crappy hack for the trace info. I guess it's okay. We do this here. Okay. So that looks good. CPU takes IRQ enabled. We increase the size of the pimpled class. We added the vector table for interrupts. Oh yes, this. So yeah, this was from last stream. For surprisingly, it looked like initializing interrupt mask to 1 made it so that we would never get interrupts because no code would set it to 0, which was rather surprising, right? That is rather surprising. Let me try it again just to be sure that is indeed what's happening. So this here. And I had read somewhere that these were 1 on resets. I don't remember where. I must have read it somewhere because that's why it's like that. See, now if I press F, nothing happens. Because the CPU is currently in a state where interrupts are inhibited. See, I is capital here, means it's set, and it needs to be 0. So that's what we had seen last time. So this is really odd. So that, yeah, that's a big question mark for me. And I'm not sure about fast interrupt mask, but that's the case right now for here. So I'll put a little note here, and I'll say but games like 3D Mindstorm expect how can I say here? Don't explicitly set it to 0 and expect IRQs to trigger. So I guess it should have been reset to 0. So So maybe someone who's watching the stream will be able to give me an answer to this. Like, I think I read that this was supposed to be resettable to 1. It seems a bit odd to me that a cartridge that would be waiting for IRQ wouldn't explicitly make sure that the interrupt mask is 0 in order to receive IRQ and rely on the hardware state. So yeah, that seems odd. Most likely the cart is doing something to set that flag, and maybe my CPU implementation is not doing it right. That's all I can think. Maybe that and CC here, although it actually says not to update CC with it, so I don't know. There's something. Anyway, I'm gonna remove this optimization here in the no in line. Don't need that anymore. We've got our push CC state, execute instruction, and we've got our wait for interrupts, IRQ enabled, and then the handling of CWAI. So much stuff going on here. Okay, so we change the number of cycles and we change this to immediate. Yeah, in the VIA we've added the CA1 interrupt flag. Oh yes, I made this change off stream after speaking to Pyro ESP. Interrupt flag for CA1 is set when the CA1 line goes from disabled to enabled. Yeah, so from disabled to enabled, and is cleared by a read-write on port A. So that's it. I'm just detecting that when there is a change on CA1 and it just went from disabled to enabled, then we set the interrupt flag to true here. Writing to port A or reading to port A clears it. And then in the interrupt flag here, while what is this again? Clear interrupt flags for any bits that are enabled. So yeah, we clear it here in case that bit's enabled when we write the interrupt flag. And when we get it, we use that. So those are the changes there. So technically this could be a separate change, but anyway. Yeah, I think I'll commit this as a separate change. Break it up a little bit. I'll say here CA1 CA1 line value, so CA1 value from interrupt flag, and make sure to set interrupt flag when CA1 goes from disabled to enabled. Okay, so we'll commit that. I think all of this here, CPU, CWAI, and then the debugger stuff that goes with it, this is all implement CWAI and a little bit more. So I'll put here CPU implement CWAI along with IRQ handling. And I'll just make a little note here. CWI is a bit weird because it's the first and only instruction we implement that puts that doesn't fully execute perspective of the CPU execute instruction call. As such, the debugger has to do a little more work to detect whether execute instruction actually did execute something based on cycles returned, and make sure not to add trace, etc. if no instruction really executed. I'm probably gonna have to revisit this code at some point. I'm not sure I like this kind of messy abstraction I've got. What I might want to do is have execute instruction maybe return the fact that whether it did something or not. And rather than base it off the fact that CPU cycles is like I'm not sure I like checking whether CPU cycles is greater than 0 to know if it did something. It makes sense, but feels a bit weird. So we'll see. Now what I have left, so I have this trace I can delete. My compatibility list for 3D Mindstorm. I have this bit of code and I'd like to do something with it. Like I said, some kind of like fake imager emulation. Maybe I can like map that to some key for now. But before that, let's see if there's another game we can test. Okay, so this is the one we were just working on. So Bedlam apparently uses CWAI, so it'd be very interesting to see now if Bedlam actually works. So let's give that a whirl. Oh, so it looks like I have something funny going on in my own implementation in terms of CPU cycles here. Look at how to handle cycles for this instruction. So what happened here? So we're definitely getting further. So this was at 913 in the CPU. Oops. Oh, okay, so we got back a CPU op for something that has 0 cycles. So what would that be? I should print it out. Oh wait. Need to kill this. Whoops. Aha! RTI. Okay. So here is actually, this makes sense. So I was expecting RTI to be something that 3D Mindstorm would use, but it didn't. It used CWAI. In this game, or I mean, it didn't use RTI, I guess. I don't know. But in this game, it looks like it does need RTI, and I'm gonna guess that if we go back enough in the trace, we'll see a CWAI somewhere in here. But anyway, let's implement RTI. Return from interrupt. So why did I have 0? Why did I have this -1 here? I guess, oh yeah, because it's really not. Why do I have -1? I guess because it really depends on. Yes, that's right. It's the kind of instruction where the number of cycles will depend on whether we are popping the entire state or a partial state. So it's kind of like, yeah. Yeah, exactly. So let's go take a look. RTI. See, depends on E. So we've got here RTI, and then we've got 2 cases. If E is 0, it's going to be 6. If E is 1, it's going to be, looks like 15 cycles. So it's all here. Okay, so let's do that. Alright, up RTI. This is an instruction that has no operands, and what we need to do, opcode fetch, don't care. So we have to pop SP. So that's a pop 8. So we'll say here, actually what we'll say is this, cc.value is equal to pop 8, right? From SP. So we pop the cc's value, and then we look at E. In fact, you know what I'm going to do is I had written that helper function to push all of it. Let's write the helper to pop all of it and return the number of cycles. So let's go here, push cc state, so we'll do it here, if cc.entire now we're going to want to pop the rest in reverse. A goes up, B goes up here, dp, x, y, u, and pc. Hey, Fly Mario. Yeah, that's exactly the right console, the very one. It was driven by a vector screen, and the colors did come from a cellophane, or I don't know if it was cellophane, but from some kind of overlay. So if you hang out long enough, you'll actually see what that looks like when I run it. What's going on here? Oh, I know why. Okay. It's because I left this code here. Neat, I like the old XY screen. Sometimes I put my oscilloscope in that mode and drive the dot about. Yeah, it's really, really cool. Really very interesting, the Vectrex. Oh no, it's not SP, it's S. That's why. Alright, so we do this. And I want to return how many cycles that took. So, in fact, I don't want to return. I think I'm just going to add cycles like I've done in so many places. So maybe I should be doing that for the push CC state. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's technically 11 cycles for this bit. Don't know what's easier. I'll try something. Let's go like this. Now if it's not entire, then I think we just have to pop the PC, right? Yeah. And sorry, this would be pop. So everywhere we see push, it become pop. And here we pop the PC. Alright, and then these become return values. So these go on the left side. Yeah, 6809. Okay, so that's the pops there. Here we want to pop to PC. And there is a question of whether the entire flag should be turned off after this. I don't know. Alright, so we go back to RTI here. So return from interrupt needs to pop this CC state. I want to know if entire had been set. I guess I'll call it the same thing. Popped entire. And oh yeah? Yeah, I think the 6809 was a relatively popular chip. One of my friends was telling me that he, like a few years ago, had bought a fairly modern kit to build like an old console, an old game console, and I think it came with the 6809. Or at least some variant of the 6809. Yeah, that sounds familiar. I'm sure if we look it up on Wikipedia, we'll find out like the popular pieces of hardware that had one in it. So I think here we're pretty much done because the PC now has the value. I do need to do the cycles thing. So I'll say if we popped entire, we'll say it's 15 cycles. Otherwise it's 6. So yeah, I think this is the reason why I went with the just not doing the cycle counting inside these functions and bringing it to the higher level, because I just think it's easier to follow, even if it's like means maybe repeating myself if I have to call pop CC state in a few places. So we'll see. But for now, I think this is simpler. So is there anything else RTI has to do? Let me just double check here. I don't know if I have to. I don't think so. Oh, I was saying that I was worried here about entire, but actually I don't need to, right? Because we will have popped. No, that's it. That's it. No, it's because it will have been saved here. So yeah, I don't know. Maybe we just leave it alone and we don't care about it. Because ostensibly, if you're going to be using CWAI, at that moment you'll want to pass in a flag of, you know, or you'll do something about the east bit. Oh, you were in the Navy. So you were into assembly. Oh, that's cool. Yeah, so I think you'll like this. Let me see if this actually works. Oh, actually, I wanted to test Bedlam. Let's switch here into Bedlam. So yeah, see, there's the cellophane you were saying. Oh, this is the overlay. See, without the overlay, it looks something like this. All right, yeah. So I'm getting a failure here because the CPU cycles. It's not being set. Okay, maybe I'm gonna change this instruction and allow it to be 0. Because in terms of, I mean, I have a couple of ways I can do this. I can add some base cycles and then add extra. Oh, thank you. Thanks for saying that it's nice. Yes, well, that's totally an effect that I was going for, the phosphors decaying, which is something I did in a shader. So it's quite interesting, the implementation. So I kind of have two ways I can go about this. I can put 0 here, change my code to allow it to be, say, greater than or equal, you know, which... Actually, to be honest, at this point, I guess I don't need to check anymore, because I mean all of them. That was the only one that I had left that was non-zero, or like 0 or less. No, I also have reset here. Oh, thanks for the follow, Fly Mario. Appreciate it. And then the other way I can go about this is I could do the breakup and say, well, RTI takes at least 3 cycles, and then the rest will depend on what we do. So, I don't know. Okay, let's do this. Let's put 0. I'll leave this with -1, so we'll catch it if ever we get a reset. And I'll just say, if it's assert that it's greater than or equal to 0 for now. Let's just see where it takes us. I should be stopping streaming, but I'm kind of excited to see if Bedlam works, so hopefully this will be the one. Oh, this looks somewhat promising. We have a score, level, but nothing is happening. Thanks. Yeah, it is quite a lot of work, but it's super fun. It's really, really interesting work. Okay, so we are. It looks like we're stuck in some kind of wait loop. We're waiting for something to occur. So I don't know what. Looks like we are dealing with the VIA register here. So yeah, I'm gonna have to take a look. I'm not sure. Yeah, there's a dot in the middle of the screen here. I don't know what Bedlam is supposed to look like. I forget. Do a little quick check. Vectrex, Bedlam. Oh, oh yeah, this game. Okay, so we're not getting the kind of scaling there. Oh, I'm quite sure Pac-Man came first, and then Clean Sweep is like every other Pac-Man clone that came out after it. Although Clean Sweep is pretty interesting. It's got a nice little variation on Pac-Man, whereby you're like a vacuum cleaner and you're sucking up dust. And you get bigger and bigger and bigger until you're full, your bag is full, and you have to go to the middle to empty your bag before you can collect more dust, more dots. So that's the variation that is Clean Sweep. Okay, so as we get to the point where we see level and we see this and the score at the top, but we're not getting the render of this, we're stuck. And I'm guessing we're waiting on, maybe we're waiting on another interrupt, one of the interrupts that perhaps I haven't implemented yet. So yeah, this is kind of interesting. This is a good place, I think, to stop. And it's something we can pick up next time, which should be next Monday. So they definitely made Asteroids. In fact, Asteroids, which is called Mindstorm, is the built-in game. So if you don't put in any cartridge, there's a game built into the ROM. It's like actually in the ROM, and it looks like this. See, it's I'll make it a little bit less big because the frame rate gets affected when I'm streaming. So this is Mindstorm, and you'll see this kind of looks like Asteroids. So you've got all these dots that are being placed everywhere. You got this ship here. And yeah, you can totally play. Oh, thanks, man. You know what? It's funny you mentioned that because I've been thinking about allowing compiling binaries and letting people download them if they want to try it without having to compile the code yourself. I know it can be a daunting task getting code like this to be compiled yourself. So yeah, I at least for Windows. I don't know if you're on Windows there, but I'll probably provide some binaries somewhere of like the latest release or latest version available on GitHub. And if people want to try it, they can test it out. So yeah, so this is the equivalent of Asteroids. And I think, in fact, there is an Asteroids game that was made, not officially, but unofficially, that's a lot closer to the real thing. But I forget what it's called. So yeah, quite cool. All right, guys. So I'm gonna end it here. And yeah, if you want to join me next week on Monday, I'll continue working on trying to get Bedlam to work. All right. So thanks again, guys, for watching, and yeah, see you next time.